Okay, when will that start, sir? When is it likely to start?
Probably within 2 weeks.
All right, sir.
Sir,
So then we'll go to our center and over there we'll do through VC, right? Okay, sir.
All options will be open. You can see the live lecture, you can see the recorded lecture, you can sit in every possible option will
Okay,
be
all
open.
right, sir. Great. Finally, sir, after 1.5 years of this.
At last.
Sir,
इससे आवाज ज्यादा ये आवाज नहीं है
सर जीजेस भी अच्छा है आजू बाजू
अब ये भूल गया यार मैं उस दिन लिया था लास्ट वीक
So we can also get a copy of the digital notes now.
I
Okay.
will not send you.
QR code.
समझ लो, you don't write, you will not learn.
We will write, sir. We'll write.
हाँ.
But for documentation purposes, it's also good to have a digital copy, sir. Otherwise, we write all the notes for every subject.
Okay. Grace. This is Janet Batchman. What was the last thing we covered in the previous class?
So conservation of momentum.
Conservation of linear momentum.
We have to start collision.
So we did that question where there was a box and then the box is moving with wheels and there's a pendulum inside.
We asked you to teach us for
Angle
the
alpha pe we have to find the
we
velocity.
asked you to teach us for the UT. You told incidentally we have to start that.
Collisions. Few very important things here. There are three types of collisions. One is a perfectly elastic collision. Perfectly elastic collision. Semi inelastic collision. Perfectly elastic collision. Inelastic collision. Perfectly inelastic collision will also be referred to as plastic. Agreed? Perfectly elastic collision, semi-inelastic collision, perfectly inelastic collision. What is the difference between the two? Between the three? Perfectly elastic collision, kinetic energy is conserved. What is conserved?
Kinetic energy.
We will define a quantity called small e, coefficient of restitution.
हाँ सर ये HSC के टेक्स्ट बुक में
सर टेस्ट में आया था सर
Right. Small e, we will define right now. Coefficient of restitution will be 1 for a perfectly elastic collision. Semi-inelastic collision, kinetic energy is not conserved. Kinetic energy is not conserved. Some amount of kinetic energy is lost. Mind my language, some amount of kinetic energy. Right? E will be less than 1, greater than 0. Here, kinetic energy is not conserved. Maximum kinetic energy is lost. To put it in crude language, here both the bodies stick to each other. To put it in crude language, both the bodies stick to each other. Here,
0.
E is equal to 0. First categorization between the three. अभी थोड़ा ध्यान से सुनिए. मोमेंटम के बारे में कुछ बोला नहीं यार आपने. मोमेंटम के बारे में कुछ बोला नहीं. टाइप ऑफ कोलिजन में मोमेंटम से कुछ लेना देना है नहीं. It may be elastic collision, it may be inelastic collision, it may be perfectly elastic, inelastic, semi-inelastic. Momentum conservation has got nothing to do with what kind of collision it is. Momentum conservation तभी किया जाएगा जब there is no external force
In that direction.
in that direction. It has got nothing to do with what kind of collision it is. It has got something to do with whether there is an external force or not. Something to do with whether there is an external force or not. Is that clear?
Yes, sir.
Yes, sir.
First, make a note of this.
So can you repeat what E is?
Coefficient of restitution is coefficient of restitution. And what is this coefficient of restitution? Technically, it is impulse of reformation upon impulse of deformation. I'll derive that. First of all, take it down till here.
Sir, आपको पता है now we are ahead of flagship in one of the tracks.
Good. Congratulations.
सर सर आप आज की इसकी रिकॉर्डिंग भेजने वाले हो कि नहीं?
Already uploaded it.
सर क्लासिज्म हो रहा है फ्लैगशिप और जेनिथ 1 में.
एक क्लास आगे एक क्लास पीछे क्या फर्क पड़ेगा?
नहीं सर, वो लोग हमें लोअर कंसीडर करते हैं वैसे.
न्यू टर्म क्लासिज्म.
Tell me when I can proceed.
Yes, sir.
Yes, sir, you can.
Sir, in semi-inelastic, only some kinetic energies possible. Okay, sir.
Maximum loss in kinetic energy happens in perfectly inelastic collision or a plastic collision. Can I proceed?
Yes, sir.
Yes.
Now, have a look at this. You have a body of mass m1 moving with a velocity u1, m2 moving with a velocity u2 at the instance of collision. These both bodies, when they come in contact, this is n delta t and this is n delta t. What is this n delta t here? N is a normal force. The concept of F external is delta P by delta T. Who told you this?
Newton.
Newton's law, second law of motion.
Newton's second law. Delta P will be F into delta T. Force into delta T will be the change in momentum of M1.
Yes,
Force
sir.
into delta T will be the change in momentum of M2. Once they restructure themselves, this will be moving with a velocity V1. This will be moving with a velocity V2. V1. Right? First, the two bodies come in contact. When they come in contact, there will be slight deformation. After deformation, they will reform. When they reform, you will come back to those velocities.
Yes, sir.
Listen to the catch in this. Is this collision elastic, inelastic, semi-inelastic? हमें कुछ लेना देना है नहीं उससे. That will speak only about conservation of energy. If I consider only M1 as a system, there is an external force called N delta T, yes or no?
Yes, sir.
Yes.
Momentum of M1, I will look at this minus N delta T is equal to final momentum M1 V1 minus initial momentum M1 U1. My first equation. Why did you put a negative sign here? Direction. All throughout momentum, force or vectors, do take the direction into consideration. M1 V1 is towards the positive x-axis. M1 U1 is also towards the positive x-axis. N delta T is towards the negative x-axis. So change in momentum will be final momentum minus initial momentum. So only M1 taken as a system, momentum is not conserved. In fact, there is a change in momentum which you calculated. Take M2 as a system and delta T positive x-axis. Final momentum M2 V2 minus M1 minus M2 U2. This is my second equation. Do you all agree with this?
Yes.
Yes, sir.
So M1 there is a change in momentum, M2 there is a change in momentum, M1 and M2 put together there is no change in momentum. Why? N delta T will become an internal force if I take all of the system put together.
Yes.
Take whole of this one system, N delta T N becomes an internal force. Add both of them, what do you get? 0 equal to M1 V1 minus M1 U1 plus M2 V2 minus M2 U2. Now M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2.
Yes, sir.
This is what we mean by conservation of linear momentum, but it is at your discretion to understand what you take as a system. You take only as M1 as a system, there is a change in momentum. Only M2 as a system, there is a change in momentum. Both M1 and M2 taken as one system, there is no change in momentum. Momentum is conserved, but both taken as one system, there is no external force. Is the logic clear?
Yes, sir.
Yes.
Take it down, Tarun.
So you consider right as positive direction as and left as negative, no?
Yes.
Go by the number line. Number line. This is positive, this is negative.
Okay.
Done, sir.
बच्चों को एक वीडियो दिखाना है यूट्यूब से होगा इस पर?
Yes, sir.
Sir, 1 second.
Done, sir.
Now, what did you define small e as? Technically, small e. Before I proceed, I will redraw this M1, M2. When they come in contact, when they are in contact, M1, M2, when they are in contact, wedge constraints याद है आपको?
Velocities along their common normal are
Velocity
same.
along common normal is the same.
Along the common normal, both will have the same velocity. I will call it V common.
Yes.
This will be U1. This will be U2. So after the collision, M1 will be moving with a velocity V1. M2 will be moving with a velocity V2. Right? First of all, what happened here? These two bodies impinged on each other, and there is a deformation. The body gets slightly deformed. Right? Now, when they reform, when the bodies regain their original shape, they are moving with V1 and V2.
Yes.
Right? Now, taking M1 and M2 as one system, you can write M1 U1 plus M2 U2 is equal to M1 plus M2 into V common. This will be equal to M1 V1 plus M2 V2. I conserved momentum taking M1 and M2 as one system.
Yes, sir. Yes.
What did you define small e as? Coefficient of restitution. This is called impulse of reformation. Upon impulse of deformation. Impulse of deformation. Impulse of reformation upon impulse of deformation. Reformation. This will be, what is impulse? Change in momentum. What is impulse? Defined as change in momentum. Right? I will take for M2 V2 minus M2 V common. Change in momentum of reformation. It reformed M2 V2 minus M2 V common. Deformation. M2 V common minus M2 U. Agree?
Yes, sir.
M2, 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 M2. V2 minus V common. I'll substitute from these two. Why not these two here? I have V2 in the numerator. So I will use V1, V2. V common, I will bring M1, M2 to the denominator. M1, V1 plus M2, V2 upon M1 plus M2. Are you okay with that?
Yes, sir.
V common minus, V common I will have
Substitute.
V common in the denominator, I use these two. In the denominator V common, I will use these two.
Okay, sir.
V common from here will become M1 U1 plus M2 U2 upon M1 plus M2 minus U2. Agreed? Denominator V common, I used these two because I need to get in terms of U. Numerator, I need to get in terms of V1 and V2. Take LCM. This M1 plus M2, this M1 plus M2 in the denominator will get cancelled out.
Yes, sir.
Agreed?
Yes, sir.
M1 V2 will survive, but M2 V2 and M2 V2 will get cancelled. Have a look at it. M2 V2 minus M2 V2. Agreed?
Yes, sir.
So M1 V2, M1 V2 minus M1 V1 upon, have a look at it. M1 U1 will survive. M1 U1. M2 U2, M2 U2 will get
Cancel.
cancelled out.
Cancel.
Right?
M1 U2 will survive.
M1 U2.
M1 U2. Cancel out M1
V2 minus V1. V2 minus.
V2 minus V1 upon U1 minus U2.
Yes, sir.
Velocity of separation upon velocity of approach is called as coefficient of restitution. Velocity of separation upon velocity of approach is called coefficient of restitution. 2 minus V1. Quite a few textbooks write this as
Hi.
small e V2 minus V1 with a negative sign in front of it,
V2 minus.
minus U1.
Yes.
So whichever you are comfortable with, do remember only one. V2 minus V1 upon U1 minus U2. Separation approach. Numerator में separation, denominator में approach. Numerator में separation, denominator में approach.
Yes, sir.
All of this chapter will be using this. Even in your sleep, you are not supposed to go wrong with a negative or positive.
Sir,
Ah,
sir, if V common is changing to V1, there must be a force, right?
exactly.
So,
Common will
perfect
change V1 and V2. If only M2 is taken, the normal force is the root cause. But if both are taken as one system, then momentum will be the same.
yes, sir. Acha.
You took M2 as one system, then V common will change to V2, so momentum of M2 change. We have no problem with that statement.
Yes, sir. Thank you.
इस पर भी होता है.
नहीं हो रहा है.
हो रहा है.
क्या
नहीं
सर?
हो-
सर आवाज नहीं आ रही.
हाँ सर, थोड़ा जोर से
सर
और.
थोड़ा जोर से
हाँ सर,
बोलो.
बहुत आइकॉनिक सा साउंड है वो.
नेसेसरी है समझने के लिए, वरना समझ में नहीं आता.
बहुत satisfactory है.
Done.
सर 1 मिनट
2 minutes.
डन सर
Now listen. What did you tell me? In a perfectly elastic collision, M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. This has got nothing to do with what kind of collision it is. Elastic, inelastic, semi-inelastic. I damn don't care. External force on M1 and M2 put together is 0. Conserve the total linear moment. Right? Now, if it is a perfectly elastic collision for a perfectly color select karo,
Red.
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 perfectly rare elastic collision. You told me kinetic energy is also conserved. So your kinetic energy equation will be M1 U1 square plus half M2 U2 square is equal to half M1 V1 square plus half M2 V2 square.
सर ये तो एनर्जी कंजर्व जैसा लग रहा है.
तो मैंने क्या बोला है?
सर ने काइनेटिक एनर्जी बोला.
तो सुनता नहीं ना ध्रुवन.
So 1 Bitcoin, sir.
नहीं.
1 बिटकॉइन तो ज्यादा ही महंगा है.
नाम क्या है उस बंदे का?
Dhruvel.
ध्रुवल सर.
Well, याद रखूंगा.
ध्रुवील ठक्कर.
Very soon we'll start meeting you people. अब तक खेल रहे थे आप लोग because you know we cannot reach you. Very soon we will be meeting you.
हाँ
सर
सर
आप
अभी
नाम याद
पकड़ना.
रखना शुरू कर दो, बहुत काम आएगा.
M1 U1 square minus V1 square is equal to M2 V2 square minus U2 square. Yes or no?
Yes sir.
Right? Now have a look at it. M1 A square minus B square, something that you learned before you were born.
Sir A plus B, A minus B.
U1 plus V1 into U1 minus V1 into
V2 plus U2 into V2 minus U2.
V2 minus U2. Have a look at this. Can you see this? M1 U1. Divide these two equations. Now bring this to the left. I want U1 minus V1. So U1 minus V1. See what I do to this equation. M1 into U1 minus V1. U1 minus V1 is equal to M2 into V2 minus U2. Agreed?
Yes sir.
Yes.
Forget about the equation. See what are you getting? M1 U1 minus V1 will go. M2 V2 minus U2 will go. You are left with
U1 plus V1 equal to U2 plus
V2
V2.
plus U2.
V2 plus U2. Rearrange this. V2 minus V1 upon U1 minus U2. Am I getting this to be 1?
Yes.
Yes, sir.
Yes.
This is what you told me was small e for a perfectly elastic collision.
Yes
Yes,
sir.
sir.
Yes.
Now you understood why small e is 1 for a perfectly elastic collision.
Yes sir.
Yes.
So
Perfectly inelastic collision, I don't need to prove anything. क्यों भाई साहब? क्यों नहीं prove करोगे? अरे मेरा मर्जी, मुझे यही तक करना है, मैंने यही तक किया है. Obviously, right?
yes, sir. U1 plus V1.
In a perfectly inelastic collision, both the bodies stick to each other. What will V2 minus V1 be?
0.
Zero.
A.
0.
Zero.
Wonderful.
So this coefficient of restitution is defined for the entire system, right?
Yes. So your next doubt will be when you define the impulse of deformation upon impulse of reformation, सिर्फ M2 का क्यों लिया है?
हाँ सर, मुझे भी वही डाउट आया था.
हाँ sir.
मन भी ले सकते हो भाई साहब. एक्शन एंड रिएक्शन आर इक्वल एंड ऑपोजिट.
हाँ सर, सेम ही आएगा.
वही आएगा.
अच्छा सेम आंसर आएगा.
सेम आंसर आएगा. न्यूटन इज ऑन आवर साइड.
हाँ सर, तो मेरे 1
सर
बिटकॉइन
उसने सब कुछ ये अकेले किया है.
न्यूटन में सपने में किससे बात किया है मुझे थोड़ी पता है यार. बचपन में
सर इससे लो सर, 2 बिटकॉइन लो.
सबसे लूंगा, चिंता मत करो. बहुत जल्दी
ध्रुवल
सेंटर
आपका
आने
हाफ
वाले
ऑफ
हो आप लोग.
मांगेगा, तो ध्रुवल आधा मांगेगा फिर आपसे.
हाँ सर 50%
का
कमीशन.
वैल्यू कितना है पता है तुम लोगों को?
सर
सर
30-40 लाख होगा.
सर शिवांश दे देगा सर.
सर शिवांश 100
सर वो लैपटॉप देने वाला है ना आपको.
हाँ सर महंगा लैपटॉप.
That is the story. Once upon a time, it seems a king wanted to perform a particular spiritual activity. So he tells all the people in his kingdom to donate 1 glass full of milk in a big container there placed, so
Yes,
that
sir.
next morning he can start the spiritual event. Next day morning, when the king goes and looks into, he was shocked to see that it is filled with water. Everybody thought the other people are pouring milk. क्या फर्क पड़ेगा? I'll pour 1 glass of water and I'll see. हर कोई सोच रहा था कि बाकी सब लोग दूध देंगे, मैं पानी दे दूंगा. Now you know why I told you this story.
Yes sir, समझा.
Yes.
Each one of you tell me the other is going to give you laptop, वो Bitcoin देगा. Everybody घूम फिर के बोलेंगे बाकी लोग दे रहे हैं ना सर.
नहीं, लेकिन सच्ची का दे
हम
देगा.
देंगे.
I am not that king.
So you're not gullible either.
Not?
Not gullible either.
What is that by the way?
अरे कि आप मान लोगे कि हम लोग बोल रहे हैं ये बंदा दे देगा, लेकिन
सबसे वसूल करूंगा, चिंता मत करो.
सर सर जीजेसीएच सर के पास से ले लो सर, उनका बर्थडे आ रहा है तो वो दे देंगे.
कब बच्चे आ रहा है तो
कोर्ट जाना है, वसूल करो उनसे भी.
सर हाँ, हम तो नहीं आ पाएंगे सर, आप वसूल कर लो.
Yes sir, done writing.
can I have the board?
Yes sir.
Yes. Yes, sir.
Now have a look at this. Something important. Write down this statement. Note, ये तो universal है. 2 identical bodies. 2 identical bodies. When subjected to a perfectly elastic collision, 2 identical bodies when subjected to a perfectly elastic collision. 2 identical bodies when subjected to a perfectly elastic collision. Interchange their velocities. Interchange their velocities. First 2 words, what did I say? 2
Identical bodies.
Bodies.
masses should be identical. आई बात समझ में?
Yes, sir. Yes.
Masses must be identical. Right? Prove it. This is M1. This is M. Identical bodies moving with a velocity u1. Identical body moving with a velocity u2. After the collision, M1 moves with a velocity v1. M2 moves with a velocity v2. Again M1 M2 लिख दिया यार मैंने, बताते क्यों नहीं? Right? Two identical bodies. And what was your condition? They should be subjected to perfectly
Elastic.
Collision.
Collision.
select a color.
Pink.
Oh, white.
Green.
White.
Green.
White.
Sir, right.
Yellow. Sir, yellow.
मजा आएगा. M
Oh.
सर दिख रहा है?
Sir, देख रहा है.
M U2 दिख रहा है?
हाँ सर.
नहीं सर नहीं दिख रहा.
M V1 plus M V2. What equation is this?
So conservation of momentum.
No momentum.
It has got nothing to do with whether it is an elastic,
Yes,
inelastic,
sir.
or semi-inelastic. External force on M1 and M2 put together is 0. M will get cancelled out. Now select a color.
Pink.
So red.
Sir, green.
Yellow.
Yellow. U1
सर
Black.
बहुत कम विजिबिलिटी.
सर येलो नहीं दिख रहा है.
अच्छा नहीं है सर, ये वाला अच्छा नहीं है।
Sir,
सर
grey.
पिंक ट्राई करो।
सर white दिख रहा है लेकिन yellow नहीं. हाँ सर ये अच्छा दिख रहा है.
1 plus U2 is equal to V1 plus V2. This is my first equation. Second equation should be technically conservation of energy. I will generally avoid kinetic energy equation and I will use small a. So kinetic energy is a quadratic equation. Small e is a linear equation.
Yes. sir.
So V2 minus V1 is small e into U1 minus U2. यही तो equation बताया था आपने?
Yes sir. And E is equal to 1.
E is equal.
E is equal to 1. Now simplifying both, I will get U1 is equal to V2, U2 is equal to V1. Interchange their velocities. Interchange velocities. Agree?
यस सर।
Yes sir.
Technically write this to the left, this to the right and add them, you will get this answer. Two simultaneous equations simplify करना आता है आपको?
Yes sir.
यस सर।
अब सुनो, perfectly elastic collision कभी देखा है आप लोगों ने?
Perfectly.
Elastic collision कभी देखा है?
नहीं sir.
No sir.
सर काइनेटिक थ्योरी ऑफ गैसेस में देखा है लेकिन वो एप्लीकेबल नहीं है.
Oh, yeah.
इतना बड़ा रॉकेट साइंस मुझे मत पढ़ाओ. Something that we know. Teach me something that is simple. कैरम बोर्ड कभी खेला है आप लोगों ने?
हाँ सर खेला है.
स्ट्राइकर का मास ज्यादा होता है. ऑब्जर्व किया है कभी आपने?
हाँ सर.
Yes sir.
कैरम बोर्ड को फर्स्ट टाइम जब लाइकोपोडियम पाउडर ड्रॉप करते हो आप, फर्स्ट राउंड विल बी not very smooth. The powder should get settled into the grooves of the carom board.
Yes, sir.
Yes sir.
It will be very smooth.
Yes sir.
In the second round, if you have ever observed this, using the striker, I will hit one coin. This coin will hit the other coin. They will interchange their velocities.
स्ट्राइकर रुक जाता है सर.
So that striker के साथ नहीं, this coin and that coin will interchange. Using one coin, strike the other coin. Now the other coin was at rest. This comes, strikes, comes to rest, and the other coin will move straight. Did you
Yes.
observe?
हाँ सर.
Yes sir. Even when you place 3
Ah, yes.
together and then you like strike one coin.
Now, this
Pendulum वाला
is
था.
something which is 99% elastic collision. Oh, 1% energy कहाँ loss हुआ है? Sound energy.
Sound energy.
It is 99% elastic collision when one coin strikes with the other coin. But the coin should strike the other coin. Identical masses is very essential. If they are not identical masses, they will not interchange their velocities.
Yes, sir.
Yes, sir.
Right.
समझा.
So even that Newton's cradle is a almost perfect elastic
Perfect
I am
collision.
coming to that. That immediate is the next example. सुनिए आप लोग. What is a perfectly elastic collision where no energy is lost? Agree?
Yes, sir.
Yes.
You take a steel solid ball, or even a snooker ball. Snooker.
हाँ सर समझा.
Yes. Snooker ball, hard wooden ball. थोड़ा ध्यान से सुनिए. You cannot categorize elastic collision on the nature of the body. Same snooker ball and snooker ball, when they collide slowly, it is a perfectly elastic collision because there is no deformation.
Yes, sir.
Solid spheres, rigid body, there is no deformation. Steel ball and steel ball, when they collide, there is no deformation. It is an elastic collision. Same steel ball, take and hit it hard towards the wall. It is an inelastic collision. It will have permanent deformation. Energy is lost. So don't tell me this is a steel ball, this will always be an inelastic collision or elastic collision. Depends on the circumstances. Steel ball, drop it on a hard surface. Glass, marble. Marbles, I don't know, you people might not have played.
We have played, sir.
Yes, sir.
We have played.
खेला है सर.
In our childhood, we used to play a lot.
हमने भी खेले.
Marbles, perfectly elastic collision. One strikes the other, you can see that.
Yes, sir.
Same marble, drop it from this height on the ground. There will be cracks developed in it. There is permanent deformation and energy loss.
Yes, sir.
Right? So perfectly elastic collision is circumstantial. You take a steel ball and strike with it. That steel ball and another steel ball in a small collision is perfectly elastic collision. Same steel ball, hit it hard towards the wall. It will be an inelastic collision. Take it down till here. I will show you Newton's cradle.
और ये न्यूटन ने सब कुछ कर दिया. कैलकुलस किया, फिर ये ऑप्टिक्स किया, फिर ये मैकेनिक्स किया बंदे ने.
That's why he's a genius, yeah.
A student told me once a very strange thing. He asked me, sir, we are studying Newton's laws when we are in 11th and 12th. What did Newton study when he was in 11th and 12th?
He was
उसके पीछे वाला जो भी गलत था.
Aristotle laws.
So, see, for everything there is an optimistic viewpoint. You people are in a better position than Newton. Newton did all this when he was doing his research. You are doing it once you passed out of your school, when you were born.
Yes, sir.
You are in a better position, right?
Yes, sir.
Feel happy for wherever you are, whatever you are. Ultimately,
can we
happiness
take
counts.
Sir, can we take example of bowling also for elastic collision?
Elastic collision का क्या example लोगे?
Sir, bowling जो club में होता है ना surface water
तो वो
में.
कैसे इलास्टिक कोलिजन होगा?
but mass is अलग है ना.
वही
अरे
बॉल
नहीं,
का
but
मास
वो bottles के mass तो same रहते हैं.
Pins का बोल रहा है तू.
हाँ.
पता नहीं, I'm not sure of it. I haven't seen that, nor do I have an idea. Tell me when I can rub the boat.
Yes, sir.
Yes, sir.
Yes.
Now listen, this is called Newton's cradle. स्मार्ट कोड भी पागल हो गया है, यहाँ ब्रिंजॉल कलर दिख रहा है, यहाँ ग्रीन कलर आ रहा है, क्या बोलूंगा। चलो माफ कर देते। We don't know if Newton played with this or not, but it's called Newton's cradle. This is M moving with a velocity of u. There are 4 spheres kept here in contact, identical. So this will collide with this. These both will interchange, perfectly elastic collision, solid spheres. They will interchange their velocities, and what will be the final verdict? 1, 2, 3, 4. Smart, right?
Yes.
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 Look at the question asked. What if this small m is moving with a velocity 2u? Oh, no, I will two masses m and n moving with a velocity u towards these 3 identical masses. Now they asked, what will be the byproduct? Will 2 masses with u and u come out, or 1 mass with 2u?
So two masses with one U each.
2, 3. Will it be 2 masses moving with a velocity of u, or will it be 1 mass moving with a velocity 2u?
2 masses with velocity.
Why not the other option? Why shouldn't it be 1 mass with 2u velocity?
The mass should be identical.
mass
so,
should be conserved.
so 2m mass.
Kinetic energy conserve नहीं होगा तब.
Yes, sir.
हाँ,
स्क्वायर में 4 हो जाएगा.
ओ अच्छा हाँ राइट सर.
This is half 2m into u square. Here also momentum तो conserve हो रहा है, kinetic energy भी conserve होना है, वो आपके लिए optional नहीं है. अगर if it is a perfectly elastic collision, kinetic energy also should be conserved. Half 2m into u square. अगर 1 mass with 2u velocity बाहर निकल रहा है तो kinetic energy will not be the same as that of this. Hence, if 2 masses are pulled to the left and released, 2 masses will come out. It has to conserve momentum as well as.
Kinetic energy.
Kinetic energy.
Kinetic energy.
I'll try to show you this video. Stay 1 second. इस पर ही दिखाओ. यही टाइप करना है. न्यूटन्स क्राइटेरिया. मैं डिक्टेट कर दूंगा, चिंता मत.
Sir, I had gotten disconnected after you said that initial kinetic energy. You only talked about the final kinetic energy being conserved, right?
Yes, initial kinetic energy, final should be conserved. If
Okay.
somebody thinks 1 mass with 2u velocity will suffice, they're wrong. Momentum is conserved in that case, but not kinetic energy. You may ask, why not 1 mass with 2u velocity? It will be the same momentum, but kinetic energy will not be conserved in that situation.
तो न्यूटन्स क्रेडल मतलब वो पेंडुलम वाला, मतलब वो जो होता है वो.
I'll show you. Yes, yes.
That's all.
Can I proceed?
Yes.
Yes, sir.
Space.
सर आ गया
गायब हो गया यूट्यूब वाले भी जबरदस्त खेलते हैं यार उनको जो वीडियो पसंद है वो आगे डाल देते हैं Two bodies on the left, two bodies on the right. Do you see this?
यस सर
Yes.
Yes, sir.
So it will never stop.
Ideally, it should never stop, but generally these strings will have certain elastic nature. We consider inelastic, so it should never stop, but it will stop by default because sound energy is being lost.
Yes, sir.
So ideally,
Also,
without
if
any
it's done a vacuum,
external force,
so ideally speaking, if you do it in a
shouldn't
vacuum, then you
stop,
can
right?
prolong the period, right?
तो लोग simultaneously बात कर रहे हैं.
It shouldn't stop, right?
It shouldn't stop. Ideally, it will never stop.
So also, if it's done in a vacuum to minimize.
If you people observe carefully, look at the vibration of the strings.
हाँ सर
They consume certain amount of energy. String
Yes.
vibration is energy. Sound is some energy. So gradually it will die down.
And they are not in contact at all times. Like बीच में कभी-कभी contact miss हो रहा है.
This is called Newton's cradle. All the permutations which are showing you, conservation of momentum and conservation of energy will be the consequence. Now listen. Based on this long back in one of the major tests, we gave a question. In for the question is 99% of the people went wrong. क्या
सर
बोला
ये
मैंने?
मुझे
सर
doubt
आएगा
होता
अगली
है।
एमटी में आएगा ये, उसका यही
ये
मतलब
अभी
है।
empty में है।
आज सॉल्व कर दो, एमटी बाद में देखा जाएगा।
हाँ देख लेंगे सर।
M is moving with a velocity of u. I have two masses m and n. All collisions are elastic. All collisions are elastic. Collision between this and this, collision between this and this, so on and so forth. All collisions are elastic. Find the final velocities of all three bodies. Find final velocities.
सर पहले लेटर में ग्राफ ही बना दिया आपने।
All
समझना ग्राफ
three bodies. ग्राफ पर नहीं बेटा, मोमेंटम और एनर्जी पर कंसंट्रेट कर। हिंट क्या बोला था मैंने? हिंट इसका
99% people got it
99.
wrong.
now it's your chance to decide if you are in the 1% or the 99%. You have 5 minutes.
सर आंसर तो आ गया बट सर डाउट आ रहा है।
सर वो आंसर गलत तो होगा, पक्का गलत होगा वो,
वही
because that's the answer 99% people would have got.
हाँ वही
नहीं,
क्योंकि
सोचो, दिमाग पर जोर डालो। जेई का तैयारी चल रहा है, टाइप करते रहो आंसर्स। जब कोई करेक्ट आंसर टाइप करेगा, रेज माय हैंड। I expect you people to at least come and fall into the trap. आप लोग वहां तक भी नहीं चल रहे हो, जहां बैठे हुए वहीं पर बैठे रहे।
सर ठीक है सर, पहली बार गलत आंसर डाल देते हैं।
मुझे डिप्रेशन में भेज दोगे यार तुम लोग यार सॉल्व तो करो ना यार हवा में तीर मार रहे हो u 0 0 to u है नहीं सॉल्व करो मोमेंटम एंड कंजर्वेशन ऑफ एनर्जी का इक्वेशन सॉल्व करो 0 to u ये सब कॉम्बिनेशंस नहीं सब गलत है दूर दूर तक ट्रैप तक भी नहीं आ रहे हो आप लोग कम से कम you fall in the trap I'll be happy that you walk till there Firstly, you cannot interchange the velocities. Masses are not identical. Stop doing that. That is very frustrating. Everybody is doing that. बहुत गुस्सा आ रहा है. Masses are identical. तभी you can interchange their velocities.
So did any students reach the trap at least?
नहीं, ट्रैप तक भी नहीं आए.
So can you check once more?
Yes. Nowhere close.
Sir, 30 seconds.
Listen. Very bad. Very bad.
Sir, please wait, sir. We are trying. Sir, 1 minute more, please.
In the world, there are three types of people. One category of people need to be motivated. Come on, you can do it. Come on, you can do it. बोलने से वो लोग कर दे. Second category of people should be instigated. अबे यार तुमसे नहीं होगा बोलने से उसको ईगो जाग जाता है. तो तभी वो मेहनत करके करता है. Do you know what is the third kind of people?
Yes,
Sir,
sir.
don't know,
Saints.
don't care. They are happy with that.
Saints.
Saints.
Sir, Saints आपने बोला था मैं.
It can neither be instigated nor motivated. Just imagine I'm teaching so many saints.
2m by 3 आ रहा है.
So it's the trap of normal force, like it will change. The
Normal force. इसीलिए U/3 डे टाइप किया है। U/3 कौन सा मास भाई साहब? तीनों U/3 से मूव होगा। उसको लगा लेट मी इक्वली डिस्ट्रीब्यूट टू ऑल थ्री। Now listen. Firstly, first instance, quite a few of you took this as 2m and you solved. Not permitted. Newton's laws से बोलते जा रहा हूँ आपको. Treat each individual mass separately.
Yes,
Yes
sir.
or no?
Yes,
If
sir.
you considered this as one system and interchanged the velocities, you will get a 0. Now consider this. 2m and m doesn't interchange their velocities. Even if it is a perfectly elastic collision, they should be identical masses to interchange their velocities. So first of all, after collision, what will you consider?
ये बहुत लाइट है.
Yes.
हाँ
So
सर.
that
चलेगा.
After collision, 2m is moving with a velocity v0. M is moving with a velocity v1, and this m is at rest. Collision is between these two. This will transfer momentum to this, then we will see. Here these both are identical masses. They will interchange their velocities. Right? First of all, find out v0 and v1. How do you do that? 2m into u naught is equal to 2m into v naught plus m into v1. M and m. 2u naught is equal to 2v naught plus v1. This is my first equation. Do you agree with this?
Yes,
yes.
sir.
Small e is this velocity minus this velocity. v1 minus v naught is equal to u naught minus 0. This velocity minus this velocity upon this velocity minus this velocity. Equation 1, equation 2. किसका mic on है भाई साहब? Now listen. V1 should get cancelled. Subtract. V1 got cancelled. U naught by 3 is V naught.
Sir, आया answer.
एक ही आंसर लिखा आपने U by 3. कौन सा मास का ले लूं मैं?
Sir नहीं sir अभी फर्स्ट बॉल सर लिखा है सर.
अच्छा अभी लिखा है आपने, दिखा है.
सर अभी नहीं लिखा.
थोड़ी देर पहले लिखा है सर.
Okay, fine. Listen. V naught is U by 3. This is not the answer for your information. रुको, थांबा. रुको जरा.
बहुत फर्क रहा था सर.
Fall into the trap first. This is the trap. Listen. ये कहाँ से है? V naught is U by 3. Find V1. V1 कैसा आएगा आपको? V1 is U naught plus V naught, right? U naught plus V naught is U naught by 3. This will be 4 U naught by 3. Here we expect the students to fall into the trap, which 99% of the people fall. You people are saints. You didn't even fall into the trap. You stood where you are standing. Right? Listen. 2m. What velocity you are giving now? 2m you are giving U naught by 3. This m and this m. V1 is 4u by 3. They'll interchange their velocity. So this will be 0 and this will be 4u naught by 3. This was the first option that we gave, which 99% of the students have opted for. It's wrong. And it's wrong.
Kinetic energy is not.
Small e,
Linear restitution.
small e is V1 minus V naught upon U naught minus 0. Small e is 1. तभी तो second equation आया.
फर्स्ट टू बॉल से वापस कोलाइड करेंगे क्या?
हाँ. Read the question.
Final velocity.
Find.
Final velocity.
Once again.
Find final velocity.
Find final velocity.
Once again.
Final velocity.
Find final velocity.
For solving a question, first of all, read the question. बिना question read के answer कर लोगे. And everybody wants marks. Strangely. अब भाई साहब, this is moving with a velocity u by 3. This is at rest. Don't you think they will collide again?
Yes, sir.
And what we did, we ask you final velocity. अरे कब तक collision continue करवाते रहोगे ऐसा?
Till the velocity becomes lesser than the one in
Right.
front.
This velocity should become lesser than this. This should become lesser than this. अगर मैंने यहाँ 2m के बजाय 5m दे दिया, 5 बार आपको मोमेंटम एनर्जी कंजर्वेशन करना पड़ेगा. मैंने 2m दिया है, मतलब 2 बार में आपको this velocity will become lesser than this. This will become lesser than this. अब दूसरी बार आप करोगे या मुझे करना है?
कर लेंगे सर.
I'm waiting. कुछ भी नहीं कर रहा है, बैठे हो आप लोग। इन दोनों की भी जब मोमेंटम कंजर्वेशन करना है और आंसर बताना है, मैं सॉल्व नहीं करूंगा इसके आगे।
सर हम कर रहे हैं।
सर कर
Nishit, your answer is correct. Three people typed the answers, all three are correct. नहीं, 16 u by 9 is wrong. Somebody
सर
type-
आंसर भेजा सर प्लीज चेक।
Yeah. The final velocities will be
U by 9
U by
9
4 u by 9,
9
4 u by
9
u by 9,
4U by 3
U.
rather u naught by 3. Use the
Yes.
same.
yes sir
Don't keep changing the symbol. You have to conserve linear momentum and then conserve energy, or small e equal to v2 minus v1 upon u1 minus u.
sir but kinetic energy will be quite lengthy right while solving
Not that difficult. It's only quadratic equation which creates little bit of a discomfort for us.
हाँ sir
Convert it u1 minus u1 square minus v1 square, put it as u1 plus v1 into u1 minus v2, job becomes easy. But anytime small e in elastic collisions, using small e equal to 1 will be much easier. Can I rub the board?
yes sir
Will you solve one more problem? M1 moving with a velocity u1 towards M2 moving with zero velocity. M1 after collision will come to rest. M2 after collision is moving with a velocity v. I call this u1, so I call this v2. They're not identical masses. They didn't interchange their velocities. One is m1, the other is m2. Agreed?
so can you give numbers
Yes,
to
sir.
be easier for calculation
1 second. No. Listen, question is not yet complete. पहले सुनो तो सही. Half the initial kinetic energy is destroyed during collision. Half the initial kinetic kinetic energy is destroyed during collision. During collision, find small a.
So technically this is inelastic, right? Partially inelastic.
It is not a perfectly elastic collision. Some amount of energy is lost. How much? Half the initial kinetic energy is lost. But he made your simplification easy. Initially M2 was at rest, finally M1 is at rest after collision. So your life becomes bit simple.
Sir, answer sent.
Answer is correct.
Correct, sir. Okay.
Somebody is swimming root M1 by M2 and all that. No, you need an answer between 0 and 1.
So, if we want a perfectly elastic collision, will we have to do it in vacuum so that no sound is like minimize sound loss?
Actually, yes. Vacuum, you'll almost reach 99.99% of this.
So 100% perfectly elastic is hypothetical, right?
Close to that can be achieved. The only thing, friction between the bodies cannot be perfectly zero. Hence, that 0.0001% is removed.
Okay, sir.
So now, first equation is conservation of limb. Half the initial kinetic energy is destroyed during collision. Half the initial kinetic energy is destroyed during collision. remove this part so that I can. We didn't use brown today, right? Brown. First equation is M1 U1 is equal to M2 V2. First equation, is everybody okay with this?
Yes, sir.
Yes, sir.
Second equation, loss in kinetic energy M1 U1 square minus half M2 V2 square is the loss, initial minus final, right?
Yes, sir.
Is half of M1 U1 square. Do you agree with that?
Yes, sir.
Half. This half I will bring it to the right, this I will take it to the left. M1 U1 square minus half M1 U1 square will become half
Half M1 U1 square.
U1 square is equal to M2 V2 square. This is my second equation. Now look at the smartness in the simplification. M1 U1 into U1. What did I do?
So you took
First
M1
equation and
of
Into V2 into V2.
Yes, sir.
Yes, sir.
Do that.
so you can equate first equation in this.
Yes, sir.
Is equal to V2 by U1. Is this the coefficient of restitution?
Yes, sir.
So
Yes, sir.
Restitution is V2 minus 0 upon U1 minus 0. V2 by U1 is up. You understood how we erased the quadratic equation. Always try to erase the quadratic equation as far as possible to be on the safe side.
Safer side.
safe side.
There are a set of 10 problems on this concept which you are supposed to solve, which generally I send as assignments, but because you people are going through the pain called your unit tests, I will be solving them in the class itself. Thanks to
Sir,
Guru.
but
So can you solve 5? We'll do
अब
5 as
भेज दो
homework.
sir, we'll get practice before.
So you do half, we do half.
So we anyways don't study
हाँ, sir,
for
that is
the
okay.
test.
yes, sir. We anyways don't study
वैसे
for
भी
it.
एक ही बाकी है अभी संडे को
For the
मंडे को
unit test, how are you managing to get marks?
सर मार्क्स ही नहीं आ
Sir,
रहे
that
मुझे
is our
पता नहीं
problem, sir.
सर आपको भी पता है अभी.
I would like
Sir,
to know
secret
and
is-
understand your problem.
Sir, recording बंद कर.
Sir, recording थोड़ा बंद करना पड़ेगा.
Sir, smart solution. अरे smart problems require smart solution.
सर
Sir,
पढ़ते
ये
ऐसा
तो
नहीं
कोड
नहीं
मार दिया
पढ़ते
बंदे ने.
और नोट्स भी पीडीएफ में है और वही तो चाहिए हमें.
वही तो सर.
टेस्ट के आधे घंटे पहले बस गो थ्रू मार लेते हैं, फिर जो होता है
हाँ
सर आज
सर
पता भी नहीं
इतना
कौन
टफ
सा
नहीं
एग्जाम
होता
है.
जो होता
सर,
है वो नहीं होता है.
सर हमें सर नहीं पता सर क्या एग्जाम के टाइम में जो मना है वो लिख देते हैं.
वही
सर
तो
इतना
सर.
टफ नहीं
सर
होता
आपकी
एग्जाम
हिस्ट्री के एग्जाम की तरह. आपकी हिस्ट्री के एग्जाम की तरह.
मेरे हिस्ट्री के एग्जाम की तरफ लिखोगे तो भी ऐसा ही आएंगे और जो
हाँ,
लोग
सर, चलेगा.
एक्सेप्शंस देते हैं आपको वो सबसे ज्यादा हंसेंगे. सो डोंट fill it up properly, right? It's okay, no hurry, let's not rush through. I'll solve it up in the classes. Don't worry, I'll give you the time.
Sir, can you share the QR code, sir?
How do we share? 1 minute रुको. Where do we share?
Sir, in the bottom left corner एक
पता है
share option है.
Share
Bottom left
option
corner.
है.
कहाँ पे दिखाओ?
सर
Sir,
बॉटम
bottom
सर
left.
लेफ्ट
तीन
Sir,
बटन है.
left side
Bottom
bottom.
left. Bottom
नॉट
left,
दिस
sir.
साइड द अदर साइड
Opposite side,
Left
opposite
side,
side.
sir. Left side.
यस सर
So the third one.
Share of
QR
QR
code.
code.
हाँ सर क्यूआर कोड करो
QR code.
QR code. Let's check the internet connection. बोल रहा है.
इंटरनेट से कनेक्टेड नहीं है।
सर एक काम करो, धैर्य को ईमेल कर दो, धैर्य हमें भेज देगा।
हाँ सर।
अरे बट उसके लिए भी इंटरनेट ही
इंटरनेट तो
लगेगा।
लगेगा ही
No,
ना।
can you ask that bhaiya over there to help?
He's doing, he's looking into, relax. What a noble man who gave the session, धैर्य को email कर दो, without internet connection email जेब में रख के भेज दूंगा यार।
आज हम बोला था
सर कबूतर
कबूतर के साथ
आज कौन सा टेस्ट है कॉलेज का?
हाँ, आज EM2 है।
EM2 या फिर CS2 या फिर
अरे EM2
Thank you.
CS2 का पोर्शन भी नहीं
अरे
बता मैं।
अरे कल EM
इलेक्ट्रिकल मेंटेनेंस।
एक सेकंड, कल EM ना, आज कौन सा है?
हाँ,
आज ही
हाँ,
EM।
आज EM है।
अच्छा,
आज भी है,
कल
कल
है
ही
क्या?
था। अभी 3:30 को है पेपर EM का।
हो जाएगा भाई।
Alternating current है।
Will there ever be a case where all
of the momentum is transferred?
हाँ, listen, I have few friends of mine here. थोड़ा बता दो यूनिट टेस्ट कैसा मैनेज कर रहे हो तुम लोग?
सर
पढ़
स्मार्ट
के
सर हम बहुत पढ़ रहे हैं
रात
यूनिट
रात
टेस्ट
तक
के लिए।
जाग
हम
कर
बहुत
पढ़ाई
पढ़ रहे
हार्ड
हैं।
वर्क हार्ड वर्क।
आधी रात
पढ़ के
Hard work
पढ़
sir।
के
There are no
रात
shortcuts to
जाग कर
success.
पढ़ाई करता हूँ।
नो शॉर्ट
सर क्लास का पढ़ाई नहीं करते, सिर्फ कॉलेज का
नो शॉर्टकट।
No shortcut sir, we study very hard.
सक्सेस।
और 5 मिनट पहले क्या बोल रहे थे आप लोग?
सेम चीज सर।
सर वो तो
सेम
मजाक
चीज
कर रहे
बोलते
थे।
रहते हैं।
हार्ड वर्क ही तो है।
हाँ सर।
प्रॉब्लम
सर
रिक्वायर्ड
कॉलेज बंद करके पढ़ते हैं कॉलेज का। सर कॉलेज
Yes,
में
sir.
यूनिट को था,
सर
जल्दी
आपके
खत्म हो
7th
गया, उसके
स्टैंडर्ड
बाद
की
पढ़ा
तरह ही
2-3
करते
चैप्टर
हैं
कर लिए।
Internet connection. Hey, there's no internet connection. This cannot be shared.
सर जिसने भी नोट्स नहीं लिखा उसका स्कैम हो गया।
हाँ
रिकॉर्डिंग भेजना पड़ा।
Hey, is there anybody who didn't write today's notes? Raise your hands. Good. Nobody rose their hands. Slowly.
कौन
you start-
admit
So
करेगा
what did you
सर?
say?
तो
Drive
कौन
today's
उठाएगा?
notes.
Admit.
राइट यार।
Right?
Write notes today.
Oh.
Good. Very good. See you
Sir.
next class.
Sir, he is trying to do something. 1 second.
सर या फिर हॉटस्पॉट से।
हाँ
वही तो मतलब
सर सारे साइड से 1 by 1 चल जाओ, स्क्रीनशॉट ले लेते हैं।
हाँ सर।
Sir, give motivation to bhaiya over here.
आर्टिस्ट स्लाइड है ना सर, ले लेंगे एक आर्ट फोटो फटो।
Situation to Bhaiya to get the internet connection.
यस सर।
Hey, screenshots एक के बाद एक दिखा रहा हूँ, screenshots ले लो.
सर फर्स्ट से जाओ ना।
सर फर्स्ट